but there you go.
Okay.
All righty. We're recording, so you can.
Okay, and
Take it
our
away.
message, John, says you cannot start screen share until the other participant is sharing.
So I'm gonna run the slides for Leonard, and he's
Okay.
just gonna, is that okay?
Yeah.
Yeah,
Okay.
Okay, so
okay.
I thought that's
we're
what we
on.
agreed on.
So
All
you
right.
can see suborbital space tourism?
Yep.
Everyone?
Okay,
Can
we're gonna
everyone
go
see that?
forward here.
Okay.
Like suborbital space tourism. Big day yesterday for me, for a lot of kind of odd reasons. One of the people on that flight was a good friend of mine, Dylan Taylor, and he, he's been up here. I know him very well, but
Right,
boy,
good morning.
being one of the 6 people on that damn thing
We were
was
worried.
a really, I'll tell you, as a writer, it gets, every once in a while it gets personal. And this is a guy I really like, and he flew on that damn thing. So he went up and he
we were
came back
nervous.
down. Next slide.
That's the big thing.
Yeah. Great guy. Amazing entrepreneur. And he's one of the 6 people. This is the first time that Blue Origin have flown in their capsule to suborbital heights, 6 people. And Dylan is on the left, here on the bottom left, and a good friend of mine. And it was, I tell you, I woke up and I'm just hoping to God this thing works. He's a great guy. He spent a lot of money on space ventures, entrepreneur. The other thing that was really kind of a medium plus was that Alan Shepard's daughter flew on this thing. Alan Shepard flew in May of 1961, and his daughter flew on this thing, as well as football player, TV mogul, whatever. But all these other people, LBDQ guy, great guy, unbelievable mixture of millionaires, billionaires, but we're getting there. And
that was his father.
his father, and it was great. Let me go to the next one. Here's some scenes I got this morning. I really think we're at some point that we don't realize, with a lot of people going up there, we have apostles at apogee. I don't want to be too corny. I haven't used this. I woke up this morning thinking that it's a AAA society of people that have gone suborbital. We're talking, pretty high up on the Blue Origin, and it's clear they had a great time. I panic, when I know somebody on there, I'm panicked about, I hope this goes well. Next slide. Great views. The one thing that was really interesting is daughter of Alan Shepard going up, and she really made emotional impact on me because I lived through Alan Shepard's suborbital flight.
Yeah.
And here's his daughter going up to pretty much the same regimen as her father. And it was great. It was just next line. I'm trying to cut through all this stuff. China space station, you know me. I think this is the big story. Keep on an eye on China. It's going to be good. It's going to get weird. Okay, next thing. We got 3 people up there now on the Chinese space station. This woman did a great job on doing lectures from space. China is moving on with their space station, trying to finish this thing by next year, 2021, end of the year. And watch this story. All I say is watch China's story. This is a big thing. It's going to have implications for the US space policy and their own, because if they fail, if they succeed, keep an eye on this story. Okay, next slide. Meanwhile, just early this month, we had another space tourism launch to the International Space Station. These 2 guys are Japanese entrepreneurs that went up and are now on board the International Space Station. There are 10 people up there. So for one moment in time yesterday, we had
11?
we had
Oh,
the suborbital people, 6 people. We had these people, 10. And we also, next slide. Oh, I'm sorry. We have the Chinese. We have the Chinese space station people, 3. So, yeah. So we had quite a few people in space on duty. Pretty cool. This is going to be usurped. This is nothing compared to what's coming. This is nothing. This is nothing compared to where we're going. Okay. On Mars, I'm going to do my little bit on Mars and Curiosity. You know, it's been there since 2012. It's moving along. It's going up the, it's going up the mountain. Cool shots, new imagery. This is just the last day or so. Great imagery from Curiosity. Again, NASA rover going up that mountain is making progress. They're looking at all the sedimentary layering. There's some cool stuff coming out of there. I'm not going to talk about it now, but there's some standby. Great stuff. Okay, next step. And then we have the other NASA rover, Perseverance, on Mars. Great imagery, minimal compared to, what I love, as we should be, the Mars Perseverance rover or helicopter. And this thing's flying above all this stuff and giving guidance to the Perseverance rover. And it's pretty cool. It went on another flight and had some problems the last go around. Pretty cool. It actually got, this is pretty cool. I mean, this is how cool. I love this stuff. It actually got into a communication problem between the helicopter and the horizon and the terrain of where it's surveying, because it couldn't communicate, the Mars rover, with we're offline now, or what happened? Something happened. Did I do that? Yeah. So it had some problems between the rover on Mars and the helicopter. And it actually got confused and landed. And anyway, this whole Perseverance rover is really moving along. Great imagery, moving along, doing samples, pulling samples out of Mars for the future of a return sample program, which I complain about, but I'm not going to get into it now. Anyway, pretty cool. Things are moving along. This is a high altitude image from the helicopter, and it's just doing great. And next slide, John. Okay. One of the big things that happened since I guess last go round, we got really problems here. Russia just contributed to a major debris dump in Earth orbit. They did an anti-satellite test. They blew up their own satellite to showcase to the world that they, can blow up satellites and when they want to. And I call them the crash test dummies. This is something that is turned out to be a, kind of a really abhorrent capability by the countries to do. We're not alone. And the Russians have done this. India has done it. Russia has done it now.
Yes.
And it's just contributed to this clutter of crap that other countries have got to deal with. And we're in trouble here. I'm going to get really mean here in the last couple of weeks. I have a lot of stories I'm doing on this. This is a bad thing. And it's a bad thing by not Russia, by US, by India. And we got problems. This anti-satellite test that they did, in my mind, was just a wake-up call one more time. I don't know how many wake-up calls we have to have, but boy, in my lifetime, I've written about 30 wake-up calls. This is a new one. And the bad thing about this, the orbit that this thing is in, International Space Station is in trouble. The Chinese space station that's being developed is in the same kind of pathway. This is becoming probably the most severe thing in ecosystem of space that we got to deal with. And I'm sorry, I'm moving on. Next thing, I think that may be the last. I don't know.
No.
Oh, John's going to talk about James Webb Space Telescope. Boy, what a flight. Wow. Here we are. The Just Wait Space Telescope is coming into view. It's going to be great. The launch of this thing is going to be a heart stopper.
Yeah.
Can they get this thing into orbit? Has to deploy. A lot of problems, a lot of issues. Great mission. I'm so old, I remember Hubble. Now, when it got launched, because Hubble was going to be the God's eye on the universe. This is the new one, and if this fails, we'll see what happens. If it succeeds, we'll see what happens. It's great story. John's going to do that. Next thing, last thing. I'm cutting out here. One of the things in my website that I made a mistake of talking about was the Chinese rover U2 2 actually saw something on the horizon that got blown up to this thing, which has created a storm. I have never had so much email in my life because of this damn thing that it saw. And it's a McDonald's. It's a dollar thing. It's a rock. It's what is it that they saw? And I have so much email on this thing that I fight every day with. I'm serious. I'm talking hundreds of people that have given their view of what this thing is, and it's just insane. Anyway, next thing. What in that vogue? Keep an eye on something new going on, because we've talked about this in the past, and I don't want to dwell on it. There's a new government office that's been set up finally to look at UAP, unidentified aerial phenomenon, UFOs, and they are moving forward on a major look at the phenomenon. And I don't want to dwell on this, but this is a great story evolving. Time travelers from our past.
Future.
Yeah.
Aliens.
Alpha Centauri people coming in. I don't know what's going to happen here, but keep an eye on this. I'm going to keep bugging you guys with this story, because this is pretty interesting for a lot of reasons. And it deals with extraterrestrials. It deals with our own capability to appreciate what is unknown. It also deals with people that fabricate things and are hucksters. We have a tremendous community of people that are all part of that. Hucksterism, people that care, people that are looking at this data. Something's going on here. And the fact that the government has actually set up a site now to look at UFOs one more time is interesting. Keep an eye on this. I think we're in for a really, what's that old thing? Keep an eye on the ride, man. It's gonna be cool. Pretty interesting. And the bottom line for me, it tells a lot about us and our ability to understand the universe at whole. And we got some surprises coming. My view is that we're on something new. And I just got in touch with Avi Loeb at Harvard. Keep an eye on this damn thing. Pretty cool. Next, that's it. I'm sorry for ranting.
No, you need to do this. Oh, are you?
Hey, quick question, Leonard.
Yeah.
I wasn't really paying attention as
Well, you should.
I paid attention to you. What I didn't pay attention to was the missions that accumulated 10 people in the International Space Station at one point.
Yeah.
And my understanding was that there was a limitation to how many people you could have up there at once, because you had to have enough spacecraft ability if they all had to leave.
Yeah.
Something bad happens. So what do they have up there as far as, rescue craft for getting back down when they have 10 people there? Because my impression was like a Soyuz would hold 3.
Yeah, the thing is, we got Soyuz hooked up there, capsules. We have also Endeavour or not Endeavor, but
The Elon Musk.
yeah, there are multiple capsules up there to hide. But look, I think we're at a point where we're in for doom. There's too many problems coming from the amount of spacecraft that are hooked up to the space station to get people out of that damn thing if there's a collision coming. And knowing that there's a collision is really problematical. You're not sure. They got these people diving in to Soyuz and some other things on the whim that something is so many miles away may come into contact with the space station. And why is that? Because we don't have direct collisional avoidance terminology. We don't know. We have a variance of debris that could come within a certain amount of time or time and distance. So we got to get better at this. I mean, they're going to have, I think, I read a long time ago that we may have to have a radar on that damn thing to actually, on the space station, to actually give the astronauts, what's in close proximity. And, at those, as well as I know, the speeds of those damn things are going. I really think this is a story that's going to be ugly. I think we're in trouble. My personal view is stand by for collision. We're going to lose a module. We're going to lose people. They won't have enough time to dive into their Soyuz. But that's me. I'm paranoid. I just want it all to be fine, but I always vary on the paranoid thing. And I'm sorry.
But is there a Dragon capsule up there right now connected? Do you know?
Huh?
Do you know if there's like a Dragon capsule connected to the ISS right now with some of those people?
Yeah, I think they can bail out right and left. I think they can bail out. They're also put into, they have ability to bail out.
So they've got,
But on the other hand, the more people that get on there, they're not going to have that much time and room to run into these other capsules. And I don't know. This is why I don't, I write articles and I don't sleep at night. I think we're headed for some problems.
so they got the Crew 3 Dragon up there right now. The Endurance is what they're calling it.
Yeah.
That's what just docked. They have a Soyuz that just brought Expedition 66 up there. They also have two Progress, which are designed to be the supply craft, but those are two Soyuz type craft. I've heard they can use them in an emergency, but I don't know if I'd want to re-enter with on one of those. I'd rather re-enter on a true Soyuz or one of the Crew. So the Crew 3 Dragon can hold 6. The Soyuz can hold 3. So there's one person who's got to climb and sit on somebody's lap or something. I don't know. That's what's up there right now, though.
Yeah.
Okay, so
not to belabor this thing, but I really do think that we got to be careful about human space flight and the public, the public interest in loss of life in Earth orbit. I think we're headed there. I think we're going to have loss of life in Earth orbit. We're going to have people that got killed because of space debris or some other malady. And I think we're going to have to get used to that. I don't know what that means. I'm just saying it's coming. There will be people stranded. They are dead because of a collision of some kind of malady in space. It could be, some other thing, but it could be space debris. I always go to the paranoid. I'm sorry. It's just, I think at some point we're going to be there and we better get used to it. And what does that mean to the public?
I don't know if we'll ever get used to that. Ugh. Cool. So, Carolyn, did you want to tell us about the?
Yeah, sure. So as Barb alluded to, Gilpin County's been dealing with a lighting ordinance, and it's really part of the planning commission. We already do have a dark skies lighting ordinance, but it's apparently not strong enough to deal with some of the extra lighting that we're seeing around the county. And so Bill Merline contacted me last summer at the fair and asked me if I'd be willing to, give some insight to the planning commission about lighting, light pollution, this sort of thing. And like I said, there is already ordinance on file, that's supposed to be enforced. And so some of the questions go around enforcement and also around the length of time you can have lights on and how bright these lights can be and that sort of thing. So last week there was the commissioners have actually had 2 work sessions and have heard public statements about the lighting ordinance that's being rewritten. And one of the commissioners still has technical issues with some of it. And so it's been sent back to the planning commission to refine the language. And some of it has to do with how bright the lights are that you can have around your house. And it's essentially about a 60-watt light bulb on your outside, in your outside lighting, but we do have a requirement for shielding and that sort of thing. So there's not really a definitive rewrite yet that I've seen, but Bill and he's I guess he's been working with the planning commission to work out the language. And I think part of the problem is we've been seeing people come in that are building or buying up homes and putting in Airbnbs and putting in a lot of lighting and not paying attention to the local ordinances. And also the county itself is something of an offender as well. And so I was talking to one of the commissioners this weekend at the Winter Arts Festival, and he was basically saying it really doesn't look good for us in the county to be telling individual residents, oh, you've got to shield your lighting and do this and do that. And then the county goes and breaks the rules. And in the current lighting code or lighting rules, the county is exempted. And so things like the school, things like county, like the transfer station, things like that have lighting. One of the things I've recommended is that they figure out a way to shield it. And there are shielding solutions that I've forwarded them information on. The International Dark Sky Association has a lot of really good information on their site about it. And I forwarded all of that, as well as implications for security lighting, which I also forwarded to the sheriff. And he contacted me at the Winter Arts Festival and said this was all very common sense. He didn't see why it would be a problem. So we're kind of waiting now until January until the Planning Commission gets the rewording done, and it will come up again before the Board of County Commissioners. I would say probably late January at the rate things are going, for another discussion. And so Barb showed up at the last meeting, and we had a few other people show up. Bill Merline was there and Bill has been much more focused on astronomy and dark skies. So I've kind of let him take that, and I've really been commenting more about light trespass and the dangers of really bright lights shining onto the highway, and people, are blinded by the light temporarily, that sort of thing. Most homes around here, at least on our mountain, there are people that have lights on. They're not real bright. There are a few that have put up those bright LEDs, and I think that's fine if they would just shield them. That would be fine. One of the things that the commission did not really take into account is that if you shield the lights, then you're really lighting the area that you're going to be working in or walking in, and you're not doing light trespass. There's already a provision for light trespass in our current code, and anybody can complain about that, and some things have been addressed. But again, places like the school, Gilpin School, they have lights shining on their fields, but they're also shining out on all the neighbors. And so the Gilpin School has not made itself a very good neighbor. So that's what's happening.
Yeah. So Carolyn, we have members from Gilpin, Boulder, and Jeffco. And as you mentioned, I kind of got involved here, and I wrote a letter to the commissioners, and I'm amazed they got it and actually read, at least two of the three read it. And
Yeah, who did you hear from? Who did you hear from?
The woman, is there just one woman? I'm not
There's
sure.
two women, Sandy and Linda.
Sandy, I think. And then the other fellow mentioned, the other commissioner of the three, mentioned that he had read my letter too. I was so thrilled. Anyway, I was representing SkyWatchers.
You're very lucky.
Yeah, I know. I know. And, just explaining that we all were concerned with astronomy good, astronomy issue for SkyWatchers. And I know it's more than that. It's really more, like you said, people in the neighborhood having the lights on. And by shielding, I think all of our members and people who are on here tonight realize that. But the big issue with the shielding is just making sure that, and we need to do that, but we don't turn on our lights, but that it's not just blasting light out, that it's shielded so it goes down onto your deck or outside your house. And doesn't.
And we've brought that up, and
Yeah.
that is part of the, I don't know if you were able to read the language of the rewritten, and it's actually going to be rewritten again, so it's probably not worth reading just yet, but I think they did understand that. He was kind of going off, you missed the previous meeting where he went off about cows giving birth in the dark and stuff, and so we kind of had to corral that a little bit.
We want them to have light.
Okay.
Well, I mean, I actually wrote him an email saying, it's been my experience, cows usually like to have their calves inside, and most responsible ranchers will have them inside when they know it's their time. And he wrote back, I mean, he's from a ranch in Kansas, so he knows this, but we had kind of a little running joke about it, but he was trying to make the point that for situational lighting, that it shouldn't be, it needs to be permitted, which we all agree on. So he does tend to get a little bit repetitive on it, and he's got a couple of points he really wants to make. This is all bound up in larger issues of development in this county, and we have a short-term rental fee now that people have to pay if they want to do an Airbnb. There's one that I've repeatedly told them about that's lit up like a cruise ship about a mile away from us. And I think if you can see it that far and count the individual lights, it's probably too bright. And one of the planning commission members lives right next door to that, and he's trying to get that fixed. And it's an absentee landlord, so he doesn't care.
Mhm.
So, that's the sort of, but there are just bigger issues involved with this, and other than just simply lighting. There's also, the planning commission's also involved in a whole development guidance scheme that they're trying to we've always had development guidance and rules about development in this county, but they're now trying to modernize it and keep it up to date, so that we don't see like one guy wanted to develop 40 homes right below us in an area where there's hardly any water or a road. So the county has really made great strides in trying to corral that sort of development. But then the lighting issue, the whole thing came up because they were rewriting all of the rules and to modernize the language. And that's when Bill sort of came in and said, well, we really need to make sure that people are shielding their lighting, and it's not on all night. Nobody has a problem if you got your light on for half an hour to work outdoors or get your animals in or whatever. But when it's on all night and shining into the neighbors' houses, then yeah, it's a problem.
Yeah, and just so you know, Bill Merline is with Southwest Research Institute, like
Right.
And so he's a scientist. He's sort of taken this on, and I just want to mention one thing. He kind of asked me to send out to all our SkyWatchers, but I'm glad I didn't with the meeting, because it went an hour and 15 minutes. I learned so much about not just Gilpin, but every county commissioners and what they're dealing with, from who's in their jail. I didn't even know they had a prison in Gilpin. But
We've got a courthouse. I've served on jury.
Yeah.
I've been called on jury duty
I
twice.
didn't realize that. But
Yeah.
obviously it should be. And they seem very nice, and I think they were concerned. And I think I want to get to John, so I don't want to go on very much longer with this. But I think one of the commissioners has 20, 40 acres, or at least 10. And he was going, well, you know, my lights don't shine. And nobody can see my lights if I've got my little porch light on, or, you know.
Oh, yeah, he's got a 60-watt porch light and he leaves it on for 5 minutes and he's worried he's going to get arrested.
Yeah, right.
And
I-
I'm sorry,
I-
that's
I
not
think-
going to happen. Yeah.
And I think, I didn't get to say this at the end, but I think if you've got whatever, 10 acres and nobody, you know, and your light's not going anywhere, or anyone around you, but then say somebody comes in, builds a home, then you need to look at that issue again.
Mhm.
But that if anyone, their lights aren't shining on anybody else's property, then, you know, they should be able to, that should be a okay thing until, you know, there's an issue. But that, anyway, we got to get on to John. I know, but thank you, Carolyn, for being so involved in this. And
Yeah, I would
Carolyn-
just say that the towns of Central City and Blackhawk are,
Yeah.
you would think they'd be more lit up than they are if you go through there. I mean, there's certainly lighting there, but in Central City, they've made a big effort to keep the lighting low as possible. So the streets are lit. They're not all completely shielded, but it's much better than I expected. So when you go through there, you're not just totally blinded like you're on the Las Vegas Strip.
Yeah.
Yeah.
Yeah, we don't want the Las Vegas Strip.
Well, no, and they know that. They actually
Yeah.
been pretty good citizens about it, and they aren't doing things like Klieg lights on New Year's Eve and stuff like that. So we're pretty fortunate there.
Okay, so John, sorry we were so long on some of these other things, but
It's totally
still
fine.
there?
I'm still here.
Yeah.
Can you
And-
hear me now?
Yeah.
I can hear
Yeah, you know, and thank
Wow.
you so much for doing this and for, you know, being our host for so many of these in the past. And yeah, we just really, there he is. We just really
Wanna
appreciate all you
introduce
do. You're so wonderful.
Introduce him, John
Yeah,
Williams.
yes, yeah. So, yeah, as you know, our local Skywatcher and NASA Solar System Ambassador, John is. I'll talk like Yoda here. And he's been wonderful about helping Leonard and I with issues and just setting this up in the past, and we truly appreciate that. And I think you're still the webmaster for the solar folks. Down
It's the
in Boulder.
National Solar Observatory.
Yeah, the solar, yeah. And does a lot of other things. And in his spare time, he's been creating a coloring book that does sort of a digital thing, or you can explain it more. John, do you have a copy of it you could show? You said you printed out a couple copies.
I actually showed it. Let's see.
Yeah, so he's been, and he recently got his master's degree at CU. And what's the name of that program, John?
It was in engineering degree
Atlas.
in Atlas. Creative Technologies was
Yeah.
the deal.
Let's
So
see that.
so there's my. Oops, you can't. There it is.
Oh, yeah. Okay.
It really is. You can't. There's a reflection. I have another
Mm.
image of it that I'll share with you all.
Okay, good. Okay,
Wow.
so we'll
Wow.
give it, take it.
Take it. I wanted to let you know that I threw a link, or actually not a link. I just threw the name of a book that I read that I thought was really good on
On the
light,
chat.
light pollution and
Hmm.
astronomy. It's called The End of Night by Paul Bogard. Came out a few years ago, but he does a really good job of going at it from a scientific perspective of, you know, bringing up these studies where they say that, you know, these lights around buildings, they don't prevent crime. There are other ways to prevent crime. And so all the things, the reasons that people bring out to have more lights are in effect wrong. And so it's a really interesting book. It was a great read. So if you have a chance, you should check it out if you're interested in that. But we're going to talk about astronomy in 2021, some of the astronomy news. And unfortunately, there's just not a whole lot of astronomy stuff going on in the sky next year that's worth noting. There's no total solar eclipses here. There's no lunar eclipses that we'll see. So next year is normal stuff, but I just wanted to, if you guys want to leave now, it's okay. No. Yeah. So Leonard, I want to thank you so much for everything that, you tell us about for the space news. And yeah, we always love your perspective and those little stories, because we know you got 1,000 of them. So I just want to keep hearing them. So Leonard talked a little bit about the James Webb Space Telescope. This is the James Webb. The thing is all fueled up, ready to go. It'll launch supposedly on December 22nd. It was supposed to launch Tuesday, but there was a little accident where some sort of strap released and it sent a vibration through the James Webb, and they spent a few days checking it. It was a strong vibration, and the instruments on board the James Webb are so delicate that they wanted to make sure that nothing was amiss, and thankfully nothing happened. The James Webb is now in it's now down in Kourou, French Guiana, at the European launch facility. And so what I really love about this picture is these guys are all dressed up and women, I suppose, are all dressed up in these spacesuits. A little different than the white, the white suited guys here, where they had this was the sun shield being tested out, and everything's looking good. This was here at where they built it in the United States. But real quick, the launch is supposed to happen at 5:20 Mountain Standard Time on December 22nd. So it's going to be early. It was intended to launch in 2010, but there's been a delay and it's way over budget. It was originally estimated to cost about $1 billion, and so far it's cost about $10 billion. And so it's going to launch on an Ariane 5 from South America. It's a partnership between NASA, the European Space Agency, and Canada, and it's going to last between 5 and 10 years. But given that we had Hubble up in orbit for 35, I suspect this will be a similar thing. Maybe not, because the Hubble got extended life from the space shuttle missions that went up to repair it and enhance it. The primary mirror of this thing is 6.5 meters. That's 21 feet. Focal length's 131.4 meters, a lot longer than Carolyn's new telescope. It has 18 mirror segments. You saw the different segments. Those gold plated things are the mirror, and the center part of it, you see, has you see those part of it there. And what'll happen is the thing will fold out. The rest of it, this is part of what Leonard alluded to. There's a lot of moving parts to this. This is probably the easiest part. The size of the sun shield, which is the harder part, is the size of a tennis court. So it's a big shield there trying to keep the telescope cool, so it can the instruments need to operate at about 370 degrees below 0 Fahrenheit. That's 50 Kelvin. So, and the orbit of this thing is going to be out at the L2, the Lagrange 2 point, about 1.5 million kilometers from Earth. And to give you an idea, there's it in orbit. This is it fully deployed. The sun shield is below, the mirrors on top. The instruments below are behind it and underneath there too. And this is a comparison of the size between the Hubble and the James Webb, compared to a person there standing in the middle. And the mission goals for this thing is to search for the very first galaxies, the first stars that formed after the Big Bang. And they're pushing back to about 250 million years after the universe formed, about 13.8 billion years now, they suspect. And we're talking, this is going back to just at about the time that stars could have formed in the universe. And please, if somebody has, if I'm saying something wrong or got something wrong, just let me know. So it's going to determine how galaxies formed. It'll observe the formation of stars at the first stages of planetary systems. And, of course, they're going to measure the physical and chemical properties of planetary systems, including stuff in our own solar system. It's going to do that through a near-infrared camera, near-infrared spectrograph, a spectrometer, and other near-infrared instruments, similar to Hubble looks at the universe in the visible light and into the near infrared. James Webb's spectrum is pushed a little farther into the near infrared, and this will give us more insight into one of the papers that I'll share here coming up that came out in 2021 is that maybe 1 in 5 galaxies that formed early in the universe we can't see because they're hidden in dust. So we can only see them using infrared. So this is the James Webb is going to be instrumental in this kind of thing. Here's a kind of a schematic of how far out the Webb is going to be. You know, the moon is 250,000 miles away, so or 239,000 miles. Hubble orbits at 354, so the James Webb is going to be pushed out quite a bit farther. And one of the reasons it's going to be out there is, one, the Lagrange points are gravitationally stable orbits between the Earth, the moon, and the sun. And I'll show you in a second, there's actually 5 Lagrange points. And, you know, the James Webb's sitting out there behind Earth at L2. And so it's going to shield it from electromagnetic radiation from Earth. It's cooler. There's, you know, most of it's just to get it away from Earth's noise. So this will be a pretty cool thing. And here's kind of an idea of what we're looking at. This is kind of the history of the universe. So at about 300,000 years after the Big Bang, or whatever inflation happened, the universe was opaque. There weren't stars. It was just this hot plasma, but their light wasn't getting through the universe yet. And it wasn't until about 400 million years after the Big Bang that stars began to form. And of course, then the galaxies formed at about the same time. And one of the other papers that came out this year, they found one of the oldest stars in the Milky Way is about 13.5 billion years. So, you know, we think the Milky Way is maybe a young galaxy, but there are stars in it that are from, you know, near the beginning of the universe's form. And then here's another idea. I'm going to show you these images from the Hubble Deep Field and Hubble Ultra Deep Field here in a second. But this is kind of the look back in time that we get from these orbiting telescopes. This is the Hubble Deep Field image, and these are all galaxies looking at a very, very tiny piece of the sky. This is, you know, there's so many galaxies, and the dimmest, fuzziest images in this, or galaxies in this image, are about 12 billion years in the past. The Hubble Ultra Deep Field pushed that back to about 13.5 billion years. And we expect James Webb to push it back even farther. Again, the brighter galaxies are foreground galaxies that are closer to us. The really dim, little tiny specks of light you see are the really, really far away fuzzy galaxies. And then if Hubble had an extreme deep field, I just thought I would share this with you. It pushes it back just a little bit farther. These galaxies that we're seeing in this image are 1/10,000,000th the brightness that we can see with our eyes. Hubble imaged about 100 days to get this image. So there's a lot of light gathering capability being done to push back our knowledge and how far back we see in time. This also is, what was this, the stat, 13 millionth of the sky. All those galaxies are just the tiniest fraction of what we can see in the sky. So it's kind of cool to think that there are as many galaxies that we can see as there are, you know, many more than there are stars. So anyway, some of the news that came out this year, and I'm really only talking in the past
John?
few months. Yeah.
Could I make comment on the web for a second?
Yeah.
You said that we don't know how long it will be active, but it has some gas thrusters in order to keep it centered in that L2 position and not drifting off eventually. And that's where they came up with the 5 to 10 year number. It's going to run out of gas at some point to station keep.
Yeah, same as Kepler. The exoplanet hunting telescope ran out of gas as well, and they can't keep it pointed anymore.
Yeah, and
It's a good point.
it'll be deployed on its way out to L2. So there's about 27 steps that have to go exactly right in order.
Yeah, I don't know what the order is, but they have to unfold the mirror unfolds, that booms falls out where the secondary mirror is, and then underneath it where the heat shield is, or not the heat shield but the sun shield, there's 5, if I remember right, there are 5 of these things, and they pop out one at a time to create this barrier. And again, it's all for keeping the telescope cool. And like what John said, all these things have to happen in order, and in order for it to work. Otherwise, I don't know what'll happen if the sun shield doesn't deploy, but Leonard will be telling us about it in the near future. So some of the papers that came out, any more questions about the James Webb that I can answer or try to answer?
Do we have anything at Lagrange points currently?
That I don't know. Anybody know? I'll find out for you, Ted. I'm sorry.
Solar observatories that are at the leading and trailing points.
I know that.
Yeah, but they're moving around.
No, right?
Isn't that the stereo pair that you're talking about?
Yeah, I mean, everything's
Yeah.
moving.
Well,
Nothing's sitting still.
it does move around, Ted, but it also keeps keeps its position in relationship to the sun, earth, and moon. Well, not the moon so much, but the sun and the earth. So when these 2 stereo spacecraft, which one of them doesn't work, when the earth moves, they move around in the orbit as well in the same sort of configuration. If that makes sense.
I thought one was faster than the Earth and one was slower than the Earth. And
Well,
they've gone from the back side of the sun, and now they're looping back around to us. So that doesn't sound like a Lagrange point. That's what I was thinking.
So they co-orbit with the Earth, and they are at the Lagrange points. We can look it up while we're sitting here. Nobody's ever looked at 2 sides of the sun at the same time, I don't think. Although there's a proposal to send a spacecraft over the poles and look at it that way.
There are proposals for that. And since I work at the National Solar Observatory, we try to keep up. Like Parker Solar Probe just recently came within the closest that it's going to be of the sun, but it's still on this, between the Earth and the sun. It's not on the other side of the sun.
Will be.
Okay,
I mean,
thanks very much. I'll go study.
No, and I would love to know. I just I don't have that answer, but I would love to know.
They're described as one in front of the Earth and one behind the Earth. I'm on the stereo site, but yeah, probably Wikipedia is probably best in the end. We can track that down.
All right. Well, while Bob tracks that down, I'll talk a little bit about some of the things that are going on. Of course, the moon right now is of great interest because we'd love to send, more permanent settlements or presence on the moon. And they found some water ice on the South Pole. This is the South Pole of the moon. But what they recently found is carbon dioxide cold traps on the moon. So frozen solid carbon dioxide. And why this is important is that they can use carbon dioxide for fuel, and they can also use it to produce other items, or use it as a resource. And so, it gives one more one more reason why we might be able to stay on the moon longer than, just sending stuff up from Earth and having to do that. So this was a recent finding that we had. Another one that just came out, I'm starting with the solar system, and then I'm going to kind of move out into the universe. To me, this is all astronomy, but there's going to be more astronomy stuff like cosmology and stuff later.
Hey, John,
Yeah.
we're getting a gray screen. I don't know if that's us or what are you seeing there and what's everybody else seeing?
I see a
I see
picture
it.
of
I
a
see
wet
it.
Mars.
Oh,
Yeah.
really? Okay, maybe it's just ours then. Okay, go ahead.
Interesting. No, it's good. If anybody sees any weirdness, let me know, because I have had problems with Zoom meetings on my computer, but I think I solved it. Anyway, a new study came out that, indicates that Mars habitability, and we're talking not habitable now, but in the past when it had a lot more water, it's always been limited by the small size. And one of the studies they used was using an element called potassium, and they used Martian meteorites, meteorites that have landed here on Earth. And there's only 12 of them that they used. But what they're suggesting in this story, in this article, is that Mars over time never ever, because of its small size, it never was going to hold the water that it had. So it had a very, very small habitable time period way in the past. Anyway, and that was kind of an interesting thing. And something related to that is that, when I was a kid, Venus was thought to be this jungle planet. Well, then we found out that it's a hell, kind of a twin hell Earth with very hot surface and no water and a carbon dioxide atmosphere. And so one of the questions has always been, well, did Venus ever have an ocean? And there were a lot of studies that suggested that was a possibility, but this new study came out from NASA that suggests that it was always too hot to have a water vapor ocean or a water ocean, and that if it had water in the past, it would have been water vapor in the atmosphere. That's all gone now, but anyway, that was sort of related to this whole idea of maybe terraforming Venus. That ultimately that's what that's for. But two other studies came out recently that give kind of some hope maybe for future missions that are going out to the outer planets. The first one was that Hubble, using old data, not new data, but old data. This is the image, the best image that Hubble can take of Ganymede, one of Jupiter's large moons, but it found evidence of water vapor well, Ganymede has this kind of an atmosphere, but it's very, very diffuse. But it found that there's oxygen in the atmosphere, in this atmosphere, and there's too much of it to be just coming off, from planetary sources or from that moon surface. So they suggest maybe that they know that there's this water ice that covers from other evidence, but they also detected this water vapor in the little atmosphere of Jupiter's moon. And then also Cassini at Saturn detected, these are plumes that are coming off the moon Enceladus, but they also detected not only water, ice, but also methane. And some of the studies are suggesting that there's too much methane, that it can't come from geochemical sources. It has to maybe be from life. So it's a possible sign of life, but it's still, these scientists are, let's put these theories out there. Other people will study them, we'll adjust if we need to, that type of thing. This is how science works. So just a heads up, we have missions that are planning to go to Juno, or not to Juno, to Ganymede or in the future, but nothing yet for Enceladus, but this is always something that can go. Moving out into the universe a little bit, we talked about Kepler a little bit. Kepler was the exoplanet hunting satellite that we had in space. so far we found 4,000 exoplanets. This number is just growing as scientists look at more data. And one of the interesting things that we just was released last week was that we found these, most of what we're finding are what are called hot Jupiters. They're large moon or large planets that are orbiting these stars. We're looking at, Kepler was looking at, one of the ways it's looking at it is if the light of the star dimmed as the planet moved across it. And so we found this hot Jupiter that's about 5 times the size of our own Jupiter, but it has a year that is only 16 hours long. And this is one of these examples of just like the water going around in a bathtub down the drain, this planet is slowly spiraling into its sun. And this is one of those examples. I think that, I mean, it whips around this little star. So that's kind of wild. One of the interesting papers that I ran across about 6 months ago was they did a study using Kepler data. They were looking at who can see, what stars are in a position to see Earth transit the sun. And they found that 2,034 star systems get a front row seat to seeing Earth move across our sun, so that they would be able to detect that there's a planet, not just Jupiter, but the Earth. And from this 2,000, there's about 1,700 of them that could actually are close enough to be able to, if they had technology, if somebody had technology similar to what we have here on Earth right now, they would actually be able to tell that Earth has an atmosphere. And maybe they would be able to determine that there's life here. And so that was kind of cool. One of the weird stories, of course, we had, our excitement a couple of years ago was this interstellar interloper called Oumuamua, but it was a small asteroid type thing that moved through the solar system. It came from outside, came by Earth, and then it's now, I don't know, out toward the orbits of Uranus or Neptune now. And it'll escape and head out into deep space. Kepler's been also detecting populations of free-floating planets. These are planets that are, in this study that I'm talking about, they were the size of the Earth, that have been thrown out of their solar systems by larger planets or other maybe interactions with other stars that have come close and just gravitationally flung them out. And we're talking not a few, there are thousands of these things that Kepler is detecting by looking out there in the same way that they look at the transiting telescope or the transiting planets with the light curves. They're seeing these things, and these planets are not they're not associated with the stars they're looking at. They can tell somehow through combination of the transits and also gravitational lensing, it says, which I find pretty interesting technology to use for this kind of thing. So stay tuned. There's many more of these planets out there, and maybe one will encounter Earth one day, but probably not. Chances are slim. One of the wildest things I've seen lately, though, is this: we may have discovered a planet outside our galaxy, and using a technique that's similar to what we use with Kepler with the light transit, visible light. This used the Chandra X-ray telescope to look at this binary star system in the Whirlpool galaxy, which is 23 million light years away. So this is outside our galaxy, and they found a planet. It would be a massive planet, but using X-rays instead of visible light. And I just think this is like bordering on science fiction. It's so cool. So this is one of those things. Last year or 2 years ago, we had moving away from exoplanets into stars now. The big topic a couple of years ago was the dimming of Betelgeuse. Now, Betelgeuse is in the left shoulder of Orion. It's a red giant star, and it's not very far from Earth. And the dimming was noticeable. with your naked eye. If you went out over the, for a month or so, you could have seen that, we're talking Betelgeuse is one of the brightest stars in the sky, and it was not even the top 100 brightest stars in the sky after it dimmed. It now has increased in brightness again, and they think this new paper came out a couple weeks ago saying or suggesting that Betelgeuse is a dying star. And one of the worries was this dimming could have been a precursor to supernova, which would directly impact Earth. And so, there was a lot of excitement in the scientific community that we might be, have a front row seat to this supernova explosion. But it appears that Betelgeuse may have just burped out some gas and dust, and this dust moved in front of the star. And similar to the exoplanets transiting in front of the star, this big thing of dust just dimmed the star down from our point of view. And so I know it's not a very exciting end to the story, but I don't know if we want to see a supernova this close. So there's trades in life that we have to do. One of the interesting things to come out lately, again, everything's interesting, I don't know why I said that, is that it seems that we found a planet that orbits 3 stars. So a trinary star system, not just, most of the stars we see out there are, binary stars. The Earth, the sun is kind of a rarity in the universe, but this star system, which is in the constellation of Orion, it's GW Orionis. This gap that you see, there's the one ring in the center, the stars in the center, and then there's this kind of gap, and then the second ring, and then the faint outer ring. Scientists are saying, well, if this were if there were no planets in the star system, the ring, the area between the first ring and the second ring would look more like the second ring and third ring. So there'd be kind of some haze in there. But they think that based on some of this observation that area is clear of debris, that there may be a Jupiter-sized or larger planet orbiting around the star and in a stable orbit around all 3 stars. So this was coming out of the ALMA. This is not, ALMA is a radio telescope, so that's why the image is kind of the way it is. One of the interesting supernova to me, I talked about, it'd be cool to see it with Betelgeuse. And any observations, anytime we see a supernova, it's kind of a rare thing. There have only been 10 in the past 1,000 years that we've seen from Earth. And one of the findings that we found lately deals with the Crab Nebula, this is a image of, it's kind of an image of X-ray and visible light from the Chandra and the Hubble Space Telescope. But what scientists from UC Santa Barbara and the Las Cumbres Observatory suggested a few months ago was that the Crab Nebula is probably the result of what's called an electron capture supernova. Now, this supernova type was theorized about 40 years ago. If we go back to our basic astronomy class, there's 2 types of supernova that we have observed and we kind of understand pretty well. One of them is when there's a white dwarf around a larger object, and the white dwarf will pull off material from this other star, and eventually it reaches a critical mass and that material explodes. This is called what is it called?
Type 1A.
Yeah, there's anyway, it's a type 1A supernova. And what happens in the second one is that it's an iron core. As a massive star dies and all the hydrogen burns out or is consumed, it collapses a little bit and it starts to burn a little hotter. It starts to burn hydrogen, and it'll work its way up through the periodic table all the way up to iron. And so at this point, the the core of the star is an iron core. This is how we get our, elements such as oxygen and carbon and things like this, all the way up to iron. This is how these elements are made in the cores of these stars. But what happens then is that once it reaches this carbon stage, it collapses on itself, and then it rebounds and explodes. And what a very, very spectacular supernova. So, and then in the core of these stars, during the supernova process, this is how we get the heavier elements, such as uranium and all these other ones. So the electron capture supernova is sort of in between those two, and it's not massive enough to have, it's similar to the iron core supernova type, but instead of iron core, it'll have either an oxygen core or neon core or magnesium core. And it's just not massive enough. But what these electrons, they smash into each other, they smash apart. So basically this removes the electrons from these elements, and the core of the star then just buckles and then explodes after that. So they think that the Goldilocks, or the Crab Nebula, which we saw in the 1000s, and not 1000s, in 1200s, I think. It was visible for like 3 weeks. It was a very bright supernova, and they think that maybe the reason why is because it was this special type of supernova. So something to look into if you're interested in this kind of cosmic cataclysm thing. But like I said earlier too, one of the findings is that that Kepler is going to look at is, these early galaxies. Like I said, 1 in 5 galaxies may be hidden in cosmic dust. The infrared nature of the James Webb will help us unravel that a little bit. One of the things that scientists found is that this is not a real image. This is an artist's rendition of it, but just like a kid, or your dog eating a cracker, there's junk, and just, they're not very messy. They're very messy eaters, I guess I'm saying. Black holes do the same thing. And so they've detected a black hole that has eaten a star, and they really have seen, what they're seeing is the ultraviolet remains of the stuff that it didn't eat. And so this is an artist's rendition of that thing. They've found the closest pair of supermassive black holes to Earth. Now, when I say close to Earth, it's a really relative thing. These massive black holes are still in another galaxy. So they're very far away, but there are 2 of them that are about 1,600 light years apart. And eventually they'll form into one single black hole, but this is the closest pair that we've been able to detect. We haven't found any in our galaxy yet, but this, sometimes we work far away and move in, so they know what they're looking for. Stephen Hawking, I think everybody knows who Stephen Hawking is. He's not with us anymore. He died a couple years ago, but he had, in 1971, he came up with this theory of, it's called I'm sorry, there's so much going on. I had to write notes, and I'm looking at this now. So in 1971, he predicted that a black hole's event horizon, this is the area where you can't return from. But this event horizon, which this thing depicts, this image right here, his theory says that it won't get any smaller. It will never shrink. It'll always be the same. And it's called the Hawking's area theorem. And from the LIGO, which is LIGO detects gravity waves, and they detected the first gravity waves from 2 in-spiraling black holes. So these are 2 black holes that are doing what the black holes I talked about before are doing. They're going around each other, and eventually they'll collide into one. this produces a, waves in gravity that we detected a few years ago. And it was kind of a cool thing. What they detected was, or what they found from this first gravitational wave signal, was that the event horizon did not appear to decrease. This is the first observational confirmation that his black hole theorem is correct. Of course, like science, there'll be more observations going on, but this is pretty cool that, we see, I think it's similar to what we discovered with Einstein and the eclipse and the orbit of Mercury back in 1916. With this first, Einstein predicted that space-time was curved. And so in 1916, they had a first observational evidence that actually, Mercury didn't appear in the sky where they thought it would. So it had moved a little bit, and this was all based on gravity. So we'll see what that is. One of the things that happened this year was there was an experiment done at the Gran Sasso National Laboratory in Italy. They were using kind of an interaction between hypothetical dark matter particles and the noble gas xenon in this special detector. And this is what this detector was supposed to do. Dark energy, it was supposed to detect maybe this dark energy. And they think that maybe, and I'm saying maybe, they've detected dark energy. Now, dark energy is related to dark matter as one of the explanations is why the universe is expanding the way it is. There's a lot of matter and energy out there that we cannot see that would help explain a lot of the things we see in the universe. So stay tuned for this. The chances of this being true are the scientists being who they are, they're saying, you know what, it's a possibility, but it's only a tiny possibility. And that there are other things that it might be. So this might not be dark energy. This might be cold fusion for all we know. Stay tuned. One of the weirdest things that we see lately, only because we have better detectors on Earth, is these immense sets of fast radio bursts. Now, these things have been, proposed to be alien signals, but they're probably not. There's 100 other natural causes for these things. And one of them is that there are these neutron stars out there in the universe with very, very strong magnetic fields, like this artist rendition of this thing. They're called magnetars. And what they think that there were 1,600 bursts that they detected within a very, very short period of time earlier, well, a couple of years ago, but the paper was released this year. And they think that maybe these bursts are from either within the magnetar's magnetic field, and there's something going on that's causing these bursts to come out, or what another theory that they're proposing is that they're actually relativistic shocks that are going on out in the beyond the magnetic sphere. Now, these are, as these shocks move out from the sun or from that star, that magnetar, they're moving at faster, or not faster than light, but near the speed of light, near that they're moving at relativistic speeds. And so they're suggesting that maybe these high-speed shock waves are coming off the sun. So again, stay tuned. These have been a big topic of conversation in the astronomy community, only because it's a fairly new phenomenon that we've been observing. And so it's something that's worth watching. Really quick, I wanted to go over kind of where we are in terms of our satellites. Voyager 1 and 2 are still operational. They're in the interstellar medium right now. They've been going out there for 44 years. They're 21 light hours away. Voyager 1 is, that's the farthest man-made object that we've got, and the fastest. And so Voyager 2 sits right behind it at 18 hours. New Horizons is about 7 light hours away. it's moving pretty dang fast. It's going towards its next target, Ultima Thule, which it should come up on in the next year or so. So stay tuned on that. But the other two, Pioneer 10 and 11, are non-operational, but they are out there. This is a view looking down on the solar system, and you can kind of see where the objects are. Voyager 1 is over here to the right. Voyager or Pioneer 10 is over here to the left. Pioneer 11 up to there. New Horizons is right here. And the world is Voyager 2. I must have cut it off. But this is looking at the plane of it. You can see Voyager 1 is heading up and out. Voyager 2 is heading down and out. Pioneer 10 is kind of in the plane of the solar system, but still way out there. So I'm just going to leave you with some pretty pictures. Juno Wrap Up. Juno is as a probe that we have around Jupiter right now. And I'm sorry, but these things look like they were taken from an airplane. They are just spectacular. Image of the Great Red Spot. Juno's main mission really is to explore or to help us understand the atmosphere of Jupiter. So we have lots of pictures of these swirls and stuff. And these things are so darn cool. Oh, this is an image of Europa. These things are so cool that what Barb was talking about before, I had spent some time in my graduate class. I had created this algorithm that busted these an image up into little triangles. They call it low poly, and it's back in the early days of computer graphics, to help with speed. Images came in with this kind of technology, but I think it's very artistic, especially when combined with astronomy stuff. And so I created 6 coloring books with spaceships, and here's the covers of them. And well, I can share with you that right now they cost way too much. They're one-offs, and I've done them, but I'm trying to get the price down so that we can all enjoy them. But they're kind of cool I've colored a little bit of them, and they're kind of interesting. And then there's some pretty pictures of the Hubble, from the Hubble lately. This is from the Running Man Nebula in Orion. And this is one of the best pictures of this nebula, whichever it is, I can't remember. It's showing some pretty fine structure. I think the older that Hubble gets, the better. Well, of course, the more used to the scope they get. More pretty pictures. The bright stars in this image are stars in our own galaxy, not in the background galaxy. They're not bright supernova or anything like that. And I just love this image because you can see, like, near the center of this, you can see that galaxy sitting right behind, kind of edge on, and plus you can see tons of other galaxies through the spiral arms of this galaxy. And of course, this is one of the best images they've taken lately of these, near this bright star in the lower right-hand corner. There's 3 galaxies, but there's an arc, right? Can you guys see my mouse?
Yeah, we see it.
Okay, so this is actually showing this. There's a quasar right here, this bright thing, and it's a gravity lens. What it's doing is this galaxy is on the other side of this quasar, and the gravity is so intense that it's bending the light of this galaxy around, causing this arc. This galaxy here, this dot right there, and that dot right there. So this curved smiley face thing, and then these 2 little dots are all the same galaxy. The gravity is curving this space so much that it's doing this. This is, one of the coolest images that I thought came out of Hubble recently. So, like I said, I was going to share with you some of the events that are going on next year, but unfortunately, we won't have a solar eclipse here in the United States until 2024. There was just the last solar eclipse before that. It was just a week ago, and the only place to see it was in Antarctica, but the pictures I've seen of it are spectacular. So, and then last year there were two in Chile in 2018 and 2019, 20, or 2019, 2020, and then this one in 2021. And then next year, there's a total solar eclipse that'll be visible in Russia. And there's a one lunar eclipse, total lunar eclipse, and it'll be visible in Russia as well. Anybody going to Russia?
That'd be a no.
No, dang it. Well, one thing that we can look forward to, though, is that a couple weeks ago, there was a massive solar flare, a coronal mass ejection that was aimed at Earth. Unfortunately, it produced some aurora as low as like northern Wyoming. I heard that some people in Nebraska saw it. I was outside. I didn't see anything. I had the camera out, didn't detect anything. But as we're right now coming out of the what's called the solar minimum, this is the 11-year cycle of the sun, and sunspot activity increases, solar activity increases, the solar wind increases toward Earth, but the cosmic rays from outside the solar system decrease, just one of the side effects of having a more active sun. But it's maybe one thing we can look forward to is aurora. Now, flip side of that is if there's an event that's too strong aimed at Earth, it can affect our technological life, like knock out power grids and things that are planes that are traveling over from here to Europe. They travel the Great Circle routes. They drop their either they drop in altitude or they go the longer way, not over the poles. Anyway, so I digress. That was a whirlwind astronomy tour. You guys have any questions?
There was a report of the aurora being seen in Cheyenne, but that may be a greater Cheyenne area.
I heard of that, and what's funny is that I can almost see Cheyenne from my house, and I'm like, well, I didn't see any red glow. The camera didn't see any red glow or anything. So
I could believe Cheyenne was pretty dark, though.
True, and I don't doubt that people did see it there. I just was kind of bummed that I didn't catch it with my camera. Yeah, this last that last coronal mass ejection was kind of interesting because one came off the sun and it was aimed at Earth. And what's interesting is from the Solar Dynamic Observatory, and other SOHO, which is another sun observing satellite in space, is it looks like a light bulb. If it comes off as a light bulb off the side, that's going away from us. But if it comes out and it looks like all around, it's coming right at Earth. Well, one of them came off at a very kind of a slow speed, and then the second one came off at a high speed. The second one hit Earth, and that's what caused the major aurora. The second one hit Earth and it didn't do anything. And a lot of that has to do with how these coronal mass ejections, it's material, but it also is the sun's magnetic. It's like a magnet, and the coronal mass ejection comes off and it has a magnetic field of its own. And if it interacts with the Earth, like if north is up here and south on a magnet pole, if Earth is if they're in the same alignment and hit, nothing really happens. But if they do this, they connect. And that's when some weird not very good things happen to Earth. And from the National Solar Observatory, they're thinking, some of the scientists were saying, well, that they probably were of similar orientation, the Earth's magnetic field and the magnetic field of the coronal mass ejection itself. So this is one of the reasons why the National Solar Observatory built the Inouye Solar Telescope in Hawaii, is so that we can start to kind of untangle the magnetic fields. We're hoping that we can see the magnetic fields of the sun or detect them better than we are doing right now. Anything you want me to go back to? Any cool pictures you want to see? I like that one.
John, do the Cmes all come from relatively far out in the sun's exterior, or do some of them propagate farther in and then just kind of burst out with more energy?
That's an interesting question. So from what I understand, the magnetic field doesn't go that deep into the sun. I mean, deep is relative. I mean, maybe 10% of the solar surface. So it doesn't come from the center of the sun. It isn't a dynamo like the Earth's magnetic field is created. So it's created a little differently. It's a lot more, there's a lot more going on. So mainly the magnetic fields are attached to sunspots. So there'll be a sunspot on the sun or two sunspots that are near each other, and they'll share the magnetic field like this. And what happens sometimes is, those get twisted up, the magnetic fields, and it releases the energy. That's what causes the solar flare. And so these solar flares are the really high energy events. There's a lot of light, there's a lot of other X-ray energy and things like that. We can't detect here on Earth, but we can detect in space. So that happens. And then you've seen the pictures from the Solar Dynamic Observatory of stuff being thrown out in space. That's the coronal mass ejection. That's the material of the sun that's coming out. Really, what the power of that doesn't come from deep inside the sun. It comes from the surface and how intensely entangled those magnetic fields are, from what I understand. I'm not a solar physicist, so we have scientists who could explain that 1,000 times better, but generally this is what happens. And so and almost all events, coronal mass ejections from the sun are powerful. Some are more powerful than others, but generally all of them are powerful events. So like I said, what happens for instance, I was flying, I had an interview with Astronomy magazine in 1989, and I almost didn't get home because there was a coronal mass ejection that day that knocked out the power grid on the northeastern United States. And I was flying from Milwaukee, and I got in the air, and when I got home, I heard that some of the flights in Milwaukee had been grounded because of this event. And there was an event about 10 years ago in the last solar cycle where the power grids got knocked out by some sort of solar event. Now, we have evidence of some sort of event. They call it the Carrington Event. This scientist named Carrington figured out what it was. In the 1850s, there was reports of aurora, like in Colorado, miners were waking up and making breakfast and coffee because they thought the sun had come up because the sky was so bright with aurora. And then, of course, everybody's going, well, this is not sunrise. There was Cuba had reports of aurora. Parts of the transatlantic cable, back then they didn't have, everything was the Morse code, the teletype machines, and there was reports of these operators being shocked by their machines. The transatlantic cable melted in some spots. There was some lines, these touch telegraph lines that were melting in the between the spans. And that was all due to a huge event that hit Earth. I mean, it was like, direct hit of this coronal mass ejection. And it just happened to hit Earth just right. We haven't had an event since. And if it had happened before, we wouldn't know about it because we didn't have the technology. It really doesn't affect life on Earth. It affects our technological life. So if this happened today, they estimate that the Eastern United States power grid wouldn't come back online for 6 months. It would really damage things. This is why space weather has become such a hot topic with all the in Boulder, we've got the National Solar Observatory with the High Altitude Observatory, which is the NO, and NOAA has a group in Boulder, and all of these entities are, they're monitoring the sun as much as they can so they can determine whether or not something bad is going to happen. And then they warn the power industries and other satellite companies and airlines and things. I don't want to end on a sad note. I mean, the sun is a pretty cool place. So.
Show us that first swirly clouds from Jupiter. That's a gorgeous picture, the kind of grayish one.
I think they're all gorgeous. Which one, Ted?
First one.
That one. I don't know what the altitude of Juno was for this picture, this image, but still pretty impressive.
It leaves the impression that the little white dots down in the middle of that big gray area look reminiscent of Earth clouds, almost like that's a sense of scale.
Maybe we can find out. Hold on. I would like to give you a sense of scale because
hey, I just wanted to remind people, we had a speaker on Juno. I guess it was probably about a year or two ago. And what's her Juno? Well, okay, I'll think of her name. But anyway, she came and gave a great talk on Juno. It might have been 3 or 4 years ago. And she actually had ended up that day having to be in Vail and drove all the way down here, gave her talk and then drove back there that night. But I just,
That was Fran Bagnall.
yeah, Fran Bagnall. Thank you, Carolyn. But yeah, just wanted to bring that up because she was very enthused about it. And I think everyone enjoyed her talk.
anytime you talk to Fran, she's like,
yeah. Hey, John,
phenomenal.
how long did it take you to put that together? That's amazing, all those images you got and what you said about it. Did that take you like hours or?
Yeah.
Yeah, I figured.
Because you all are worth it.
What?
I've spent, I started gathering stuff earlier in the week, but I spent most of today putting it together for y'all.
Thank you so much for doing
Thank you.
Good
Yeah,
job.
yeah.
I like to do it because, I hear about all these things and I actually keep I don't know, I have a little document of stories that I want to go back and read.
Mhm.
And this is
Yeah.
a lot of those stories are what I talked about today. So it gives me a chance to catch up. So have me
Oh,
do it
good.
anytime.
Since we don't pay you very much for this.
Hold it, I'm waiting for that first check.
Yeah, right. We at least we could give you a mug. Or oh no, you ordered all the stickers, the SkyWatchers stickers.
Yeah, I'm so bummed that we haven't, I would love to give them all to you for Christmas.
Yeah,
I've got the right before COVID hit, I had ordered a bunch of what do we call them? Holographic stickers.
Yeah.
They're kind of
Yeah.
you can if you were at the 4th of July thing, you probably
Yeah.
picked them up. But anyway, I was
well,
like right
and
before COVID.
if anyone wants any or wants to, give them to somebody else or stick them on their laptop like Tammy did, Tammy Walthmath, and I've got ones on mine too, my laptop. But yeah, just let us know. Send me an email. I have some, I can get some from John, and we'll send you one, We can do
We'll get it to you
55
somehow.
cents. I'll do it. You don't have to.
Oh no, I'll meet
Yeah.
anybody at the coffee shop or wherever.
Yeah.
I need to buy a new laptop so I can stick them on it.
Yeah.
Right.
Well, Carolyn needs one for a new telescope.
Yeah. Yeah, thank you.
Well,
so
funny
much.
you should mention that. I'm getting a new computer too. So,
Oh my God.
We'll give you 2.
yeah. Alienware.
Yeah.
Oh, really?
Yeah. Yeah. I don't know when that's showing up.
I hope you get all those for Christmas. I just want SkyWatchers to be able to clear the sky for you. So the day that comes in, you can, and when you get a photo from that, send it to us and we'll send it out to the SkyWatchers.
Well, the other thing about this that really intrigues me is that they have a whole citizen science network put together of people that are combining all these telescopes to do some pretty interesting observations.
Oh, wow. I
So-
did
so-
see that there's a society of high-end
Mhm.
telescopes,
Yeah.
your kind. But yeah, that's great that they're trying to do things together, That's really neat. So, just on the chat comments, was there anything there that John, you wanted to point out? I was just scanning through it kind of. And, or Bob Grimm, because he posted a number of things there.
Yeah, Bob filled us in on what things are at what Lagrange point that Ted asked about, which is
Yeah. I'm just looking at that too. Okay. And yeah, any of you, I know John and a lot of other people have good telescopes that they have right now. And, any of those that you want to share, we'd be glad to send those out as a little visual happy holiday.